All right, team, grab your gear and get ready because today we're blowing the whistle and tackling a massive milestone. We are looking squarely at Domain 1.0 of the CCNA 200-301 exam, Network Fundamentals. This single domain makes up a whopping 20% of your final score, so we are going to build the absolute ultimate game plan to conquer it. We're going to break down the totally complex world of network devices and make it clear, structured, and honestly impossible to forget when you sit down for that test. Let's get our heads in the game.
Listen, if you're wondering, why am I putting in all these grueling hours to study this? Well, check this out. Our instructor for this material, Farrukh Nizami, dropped this absolutely incredible insight. He said, CCNA plus AI skills, that combination is commanding a 45% salary premium in today's market. Seriously, a 45% premium. That is huge. Mastering this networking foundation isn't just about snagging a passing score. It's about setting yourself up for a seriously lucrative career. The networks of the future are relying heavily on the exact building blocks we're covering in this explainer today. Once you know exactly how data moves, you become incredibly invaluable.
Okay, here's our playbook for today. First, the CCNA game plan. Second, Layer 2 local traffic. Third, Layer 3 network directors. Fourth, the highly anticipated L2 versus L3 matchup. And finally, number 5, the coach's pop quiz. Let's kick things off with Section 1, the CCNA game plan, building the foundation. Now, before we even start talking about the specific players on the field, we really need to understand the field itself. And in networking, that field is the OSI model. It's a 7-layer framework. And look, memorizing this is an absolute non-negotiable must for the CCNA. The really crucial point here is knowing the exact order from layer 7 all the way down to layer 1. We've got the classic mnemonic right here to lock this into your brain permanently. All people seem to need data processing. Application, presentation, session, transport, network, data link, and physical. Just say it with me in your head. All people seem to need data processing. As a network engineer, you're literally going to spend most of your time troubleshooting in those bottom 3 layers, which happens to be exactly where our focus is today. So let's translate all that abstract OSI model theory into actual physical hardware. Look down at the very bottom. Layer 1 is the physical layer, and that's the home to legacy hubs. Take a step up to layer 2, the data link layer, and suddenly we find our switches and access points using MAC addresses. Step up one more time to layer 3, the network layer, and we've got our routers using IP addresses. Then way up at the top, layers 3 through 7, we find our advanced firewalls and intrusion prevention systems. Just a pro tip here, always be ready to match a device to its correct OSI layer. It is for sure one of the most frequently tested topics you're going to see. Moving right along to Section 2, Layer 2, Local traffic. This is the zone where we handle all the local traffic within a single network neighborhood. We've got our 2 MVP Layer 2 devices right here, the switch and the wireless access point, or AP. Basically, think of the switch as your super efficient local traffic manager for anything with a cable. It connects devices that are sitting on the exact same network. It dynamically builds this thing called a MAC address table, so it learns exactly which physical device is plugged into which specific port, and that lets it send data efficiently and completely privately. Now, the access point does a very similar job, but it acts as a bridge for your wireless Wi-Fi clients, connecting them back to that wired Ethernet network. Both of these powerhouses live right at layer 2. Now, this right here brilliantly illustrates exactly why switches totally revolutionize networking. And heads up, the exam absolutely loves to test your historical knowledge by making you compare modern switches to old legacy hubs. So, a hub is a layer 1 device. It has literally zero intelligence. It just takes an electrical signal in one port and blindly blasts it out of every single other port. If 2 devices try to talk at once, bam, you get a collision. A 24-port hub has exactly one massive, messy collision domain. But a switch operates up at layer 2. It actively reads MAC addresses. It unicasts data only to the specific destination port. Because of this, a 24-port switch actually creates 24 separate collision domains. It effectively eliminates those old collisions entirely. Definitely lock that distinction away for test day. All right, leveling up to Section 3. Layer 3, Network Directors. We are moving out of the data link layer and up to the network layer, which is where data leaves the local neighborhood and finally hits the global highway. Say hello to the router. If the switch is your local traffic manager, the router is the GPS of networking. A router's primary job is to route data between completely different networks. So, when your laptop at home wants to talk to a server in some data center clear across the country, a switch cannot help you get there. You need a router. Routers operate at layer 3 using logical IP addresses, not physical MAC addresses. They examine the destination IP of every single packet, they check their internal map, which we call a routing table, and they figure out the absolute best path to get that data to its final destination.
And here we go, the main event. Section 4, the L2 versus L3 matchup.
Listen up, because this right here is probably the most heavily tested concept in Domain 1.0. You literally need to know the differences between these two cold. Go ahead and take a mental screenshot of this. It is your CCNA cheat code. Let's compare them feature by feature. For addressing, Layer 2 uses physical MAC addresses burned directly into the hardware. Layer 3 uses logical IP addresses. For the data unit, at Layer 2, data is packaged up into what we call frames. At Layer 3, it's packaged into packets. And finally, function. Layer 2 forwards frames within the same network. Layer 3 routes packets between different networks. So whenever you're reading a multiple choice question, scan hard for these keywords. If you see MAC or frame, immediately think Layer 2 switch. If you spot IP or packet, think Layer 3 router.
But hey, you know networking loves a good hybrid device. Enter the Layer 3 switch. In modern enterprise networks, especially at the distribution or core layers, we use devices that combine the best of both worlds. A Layer 3 switch gives you the massive port density and ultra-high-speed hardware switching of a Layer 2 device, but it also has the built-in intelligence to perform IP routing right between different virtual LANs or VLANs. So it's essentially a switch and a router packed into a single high-performance chassis. Pretty cool, right?
Which brings us to Section 5, the coach's pop quiz.
Okay, team, the playbook is installed. Now it's time to run some drills. I'm going to throw some rapid-fire flashcard questions at you, pulled straight from the class notes. Here is your first drill. Which device forwards packets between different networks using IP addresses? I'll give you a second to think. Look really closely at the keywords in that sentence. Packets, different networks, IP addresses.
And it's a router. Boom. The exact second you see IP addresses and moving data across different networks, your brain needs to immediately lock on to Layer 3, which is the router's domain.
All right, let's try drill number 2. A 24-port device learns MAC addresses and forwards frames only to the correct port. What is it? Again, isolate those key terms. MAC addresses, frames, correct port.
Nailed it. It's a switch. Because it uses MAC addresses to forward frames within the exact same local network efficiently and privately through unicast, we know for a fact we are dealing with a Layer 2 switch. If it was doing any routing, it would be a router.
Okay, last drill, I'm throwing a little curveball here about an obsolete piece of hardware just to make sure you're paying attention to your networking history. Which legacy device broadcasts incoming signals to every port, causing collisions? Yep, you guessed it. It is the hub. Remember, a hub is just a dumb Layer 1 device. It doesn't read MAC addresses. It definitely doesn't read IP addresses. It just blindly repeats the electrical signal out of every single port, sharing one huge messy collision domain. Bottom line, always, always choose a switch over a hub. Man, you all completely crushed it today. But hey, a good coach never lets their team head back to the locker room without a little homework for the next study session. So here is your assignment. Where does a next-generation firewall, an NGFW, fit on the OSI model? And why does it need to inspect traffic all the way up to Layer 7? Seriously, think about what it actually means to look way beyond just the IP addresses and peek into the actual applications being used by the client. Research that, and I promise you will be miles ahead for your exam. Thank you so much for putting in the hard work with me today on this explainer. Keep studying, keep grinding, and I will see you in the next one.